So in the last couple of lectures, we've kind of made a transition, right? We've gone from just talking about the probability of an individual having a certain property, for example, a weight above a certain number, to talking about similar kinds of probability questions, but with groups of people. So we're talking about what's the probability that the average of a group is above or below a certain amount. Well, if we can do this for averages, then it would be nice if we could do this for proportions as well, right? And it turns out we can. And the process we're going to use is very similar to what we saw previously for talking about means. So I have our theorem here, and I know maybe it looks a little big and wordy, but you'll see as we get into it that it really is very similar to the theorem we're already familiar with for talking about the mean of a sampling distribution. So first, we are talking about sampling distributions here, right? So if I have a simple random sample of size n, right? So we're not talking about an individual, we're talking about a sample, which is what sampling distributions are for. And if I know that the population proportion is p, then the mean of the sampling distribution, which we're going to call, the mean of the sampling distribution of p hat, those are the sample proportions, is equal to p. All right, so that's exactly what we saw. That's the exact same thing as what we saw with means, right? The mean of the sampling distribution is the same as the mean of the original distribution. It's the standard deviation that we have to tweak, right? And we've got a formula here to do that, right? The standard deviation of the sampling distributions is equal to this formula here. So to answer questions involving the proportions and groups, we're going to do the exact same thing that we did before. We're going to leave the mean the same, and we're going to apply this adjustment to the standard deviation. Right, now, there are a couple of caveats here to make this work. This is a little unusual, right? But the sample size has to be relatively small. The sample size has to be no more than 5% of the total population, and this has to be true, right? N times P times Q has to be greater than or equal to 10. And if you remember, you think back to when we're talking about the properties of probability distributions, that MPQ, that is the variance of the original distribution. All right, so we've got a couple things we have to test right before we start throwing this formula around. All right, so let's take an example. All right, I got a customer satisfaction survey at a multinational corporation. We know the positive response rate to this question. And what the company wants to do is they want to put together 10-person focus groups. And I want to answer this question. What's the probability that a random sample of 10 customers has a response rate greater than 80%? Okay, well, for a multinational corporation, it's reasonable to assume that 10 is less than 5% of the population. The population will be all of their customers, right? So, I mean, we can calculate this real quick, right? Let's let capital N be the population, the total number of customers they have. And I want to know is 0.05, 5% of that greater than 10. So if we divide both sides by 0.05, right, we get N is greater than 10 divided by 0.05. That comes out to 200. Well, a large multinational corporation probably has more than 200 customers. So we're going to check that box off, say that one is okay. If you're actually doing this in a practical situation, you could go and actually ask and find out their customer count and know for certain. All right, so now we have a second thing we have to check. We have to look at NPQ, and our requirement here, remember, is that this has to be greater than or equal to 10. All right, well, let's see what this is. N is the sample size, that's 10. P is the proportion who said yes, or give a positive response, that's 0.85. Q, remember Q is always 1 minus P. So this is 1 minus 0.85, which is 0.15. Now, if you get your calculator out and you do this calculation, this comes out to 1.275, which is less than 10. So we're in trouble here. The sample size isn't large enough to let us draw the kind of conclusions that the company is asking for. All right, so let's turn this around then, right? You go to your manager with this, you say, sorry, it's not going to work. Right, so they come back and they say, well, okay, well, what sample size do we need? Right, give me a number. What's my threshold for allowing you to do these calculations? So let's go back to our formula. I need NPQ to be greater than or equal to 10. Right, well, remember what I'm being asked to find. I'm being asked to find the sample size. That's N. So I want to leave that alone. Right, I want that to stay in my equation. And we saw on the last slide, I know P and Q. P is 0.85. Q is 1 minus 0.85, which was 0.15. And I need this to be greater than or equal to 10. Not 0, 10. Okay, well, this is easy enough to solve. Divide both sides by 0.85 times 0.15, and you get N is greater than or equal to 78.4. Now, that's not the answer to your question. Please do not go to the VP of Marketing and give him 78.4 as an answer. He can't survey a 4/10 of a customer. He wants an integer. And remember, when we're doing things like this, smaller, we've seen, right? If you go too small, it's not going to work. Right, so I am not going to round down to 78.4. 78 is going to give me slightly less than 10 in this calculation. So I'm going to round up and say they need to survey at least a group of 79 customers. All right, so now let's try this again. Right, this is the same question, right? Only now I've tweaked the size of my sample to meet the requirement that we saw on the last slide, right? I've raised the size of the groups up to 79, right? You can check if you go calculate NPQ, you'll see it comes out to 10.07, which is greater than or equal to 10. We're good here. Okay, so now what am I going to do? Well, let's see. I need my mean and my standard deviation. Well, the mean of the sampling distribution is just P. That's 0.85. And the standard deviation of the sampling distribution, we get that with our formula. This is the square root of PQ divided by N. So this is 0.85 times 0.15 divided by 79, square root of the whole thing, and my calculator tells me this is 0.0402. All right, now we can answer our question. Right? What was the question? Right? The question is, what is the probability that a random sample has a response rate greater than 80%? All right, so I'm trying to calculate probability that a response is greater than 0.80. All right, well, now I can just use the methods we've talked about before, right? I'm going to calculate a z-score. Then I'm going to go to my table or Excel, your calculator, whatever technology solution you use, and that should give me my answer. Right, so I know that this is the same as the probability that z is greater than 0.80 minus 0.85, that's my mean, divided by the standard deviation, 0.0402. Right, get your calculator out. This is the probability that z is greater than negative 1.24. And that's a greater than, right? We can't do greater than. It's looking at the table, right? The table and a lot of technology solutions only give you less thans. So this is the same as 1 minus the probability that z is less than negative 1.24. And now you go to your table, your Excel, your calculator, or wherever you like to use. This is 1 minus 0.107488, which is 0.892512. And that's it. That's my probability. Right, that's the probability that the response of my group is greater than 80%. So what's next? Well, we've really come to the end of our discussion of probability. Right? We're going to continue to use probabilities going forward, but for the remainder of the class, it's no longer going to be our main focus. It's going to become a tool that we use to do other things. So in the next chapter, we're really going to get into inferential statistics proper. Right? We're going to look at a technique called a confidence interval. This is a really great tool. You actually see these used all the time. Anytime, it's an election year right now, as I'm recording this. Anytime you see someone say, well, so-and-so has 58% of the vote plus or minus 1.2%. That's a confidence interval. Right? This person went out, they collected a sample, and they calculated the proportion of the sample that favored a certain candidate. And based on that and some calculations and some probability, they made an inference about the corresponding proportion for the entire population. That's what's called a confidence interval. That's what we're going to be focusing on in our next chapter.